Hello, everyone. Um, this is Karna here, and the New York Times a couple days ago decided to release all the data that they have been tracking related to COVID-19 or the coronavirus. And since I had a little bit of time, I thought it would be a very interesting opportunity to see how um, the progression of the disease uh, differs on a state by state level, with a focus on the states that are of the most interest to me. That is the states where my family members live. So in this in this video, I'm going to focus on four states: Ohio, North Carolina, where I live, Florida, and Georgia, to just kind of see how the disease progression differs um, between states where the total number of cases is not different by that much. It's not like we're comparing Wyoming to New York, for example, where Wyoming has 50 cases and New York has 50,000. So these are all on the same relative order of magnitude. So let's dive in. So I using the New York Times the New York Times tool, I just wrote a quick script in Python, and the link to the code is in the description of the video. Um, and we have, of course, four different states. And so, what's going on here? Here we see for basically all four of the states, we see these typical exponential growth curves, which is very typical of an epidemic. And um, you can see that the number of increases, the difference between one day to the next is increasing as the days go on. And on the x-axis here, we have plotted days since arrival of coronavirus in the United States. So the coronavirus, the first known recorded case was on um, January 21st, 2020, and it was in Washington. So the New York Times started tracking this data from January 21st, 2020, and so this is days since arrival of the coronavirus. We are now around day 67, I think, um, and so this is just a nice way to organize the data by by days since the index patient arrived in the United States. Um, so, what is going on here? So we see that um, that in terms of cases, Florida looks like it has the highest number of cases relative to in second place is Georgia, in third place is Ohio, and in fourth place is North Carolina. And the deaths tell a similar, although somewhat different story. So for in terms of deaths, um, Georgia has the most deaths, and Florida has the second to most deaths. Um, Now, because of the way that the United States testing has worked, the United States has been severely under testing compared to, especially in these states, compared to the rest of the world. Um, and um, it means that these numbers are actually severe underestimates. So, using the deaths as a proxy for the number of people who were infected 2 weeks ago, 2 weeks, because 2 weeks is the incubation period for the virus, is somewhat more accurate. Um, and so, according to this, Georgia and Florida are much worse off than Ohio and North Carolina. And it looks, according to the deaths, it looks like North Carolina is actually in a much better position, or actually, I shouldn't say better, in a much delayed position compared to um, the other states. So how can we get quantitative in terms of what I'm saying, the delay time? So we can we can model this exponential growth according to some very simple equations. So the the equations we're going to use, and I'm going to use a different color. Let's use pink. So the equation that I'm going to use is that the number of cases is going to be equal to 2 to the t minus d over tau. And this might seem a little complicated, but bear with me. The idea is that because this is exponential growth, the number of cases multiplies by 2 after a fixed number of days. These number of days is called the doubling time, and this is what this parameter tau represents. So tau is the doubling time. D is what's called the onset time, and the onset time is defined as the day of arrival of the first case. So that you can see that because when t is equal to d, time is equal to d, t minus d is equal to 0, and 2 to the 0 is equal to 1. So the onset time d is the day at which the first case arrives. And so this measures this what this thing measures two things. The doubling time represents how fast the disease is multiplying. And so this can be used to measure, how good are the people in that particular state, or how bad those people are in that particular state are doing at social distancing. And then this onset time is when the disease or when the first case entered into that particular region. And so these curves are actually well described by this mathematical formula. And so what we can do is we can perform what's called a regression analysis, or we can fit this curve to the data. So that's what I do here. So these graphs show the same data that I showed you, but with the exponential fit overlaid. So these are the best values of tau and d that explain the data that we see here. It's just a fit. And so from these we can read off the doubling times tau and the onset times after January 21st. So, and then additionally what I did is there's a lot of press right now about New York. So I compared all of these to New York. So you can see that this graph is not very useful because New York is so much larger than all the other states. But you can still see that New York roughly follows this pattern of exponential growth, although the growth is starting to slow because of the fact that so many people are already infected, and the ability of them to test the new cases is limited due to limited testing capacity. So here is the data or measured parameters. So this right here is tau, and this right here is d. So, and I reported the uncertainties of the fit for each of them. So you can see that all of the and this might be just a curiosity of the data and is not actually necessarily reflective of the underlying reality, but you can see that all of the states, with the exception of Ohio, have a doubling time of around 2.8. And Ohio has a doubling time of 2.7. And so the idea here is that Ohio is actually this this fact that it's 2.7, this is actually statistically significantly different from North Carolina. So these are different. But North Carolina is within the margin of error of all the other doubling times. So roughly all the doubling times are around 2.8 days. What actually is more interesting than the doubling time is the onset date. So here we have the onset date, and it can be seen that New York is the onset date is much lower than the others. And the meaning of this is that the first case in New York arrived much before the other states. So this kind of reframes the question, as I mentioned earlier. It's not necessarily that, North Carolina is doing a better job than New York. It's that North Carolina is, let's see, 16 days behind New York. And maybe that might mean that North Carolina will be able to do a better job. But we are actually behind. And if we don't do anything, we will end up like New York in 16 days. Florida has less time. Florida is only 11 days behind New York instead of 16. They are 5 days in front of us, and this is a statistically significant difference. Ohio and North Carolina are actually, they had the same onset date. But if you see, for whatever reason, Ohio has a shorter doubling time, which means that the disease grows faster in Ohio than North Carolina for whatever reason. I don't know if this is actually fully representative of some physical trend, but in conclusion, I would much rather be in North Carolina than any of these other states. And if I couldn't be in North Carolina, I would rather be in Ohio. And I definitely would not want to be in New York. So thank you for watching. I hope you enjoyed this. And everyone, make sure you stay safe. And hopefully we'll be able to do some more hindsight analysis after this is all over. And hopefully the consequences are not as bad as everyone is saying they are going to be. Thank you for watching.